If you're listening to this, your day is ending or your night is beginning, and either way, you are welcome here. There is nothing you need to remember tonight. Tonight, we will drift very slowly into the warm tropical seas where the great sea turtles glide through their patient ancient lives. This is the Circadian Institute. We make slow, scientifically grounded stories meant for sleep. The voice is steady, the pace is patient. Tonight's destination is the world of sea turtles, gentle ancient mariners who have been navigating the oceans for more than 100 million years. Subscribing is the small gesture that keeps these journeys reaching new sleepers each night. A sea turtle is one of the oldest forms still moving on the surface of the earth. Its lineage reaches back more than 110 million years, older than most flowering plants, older than every modern songbird, older than the ancestors of every mammal alive today. While continents drifted and ice ages came and went, sea turtles kept swimming. Tonight, we will travel slowly through their long, patient world, through the warm tropical seas where they feed in seagrass meadows, through the open oceans where they cross hemispheres, down into the cold, dark depths where leatherbacks chase jellyfish, and onto the moonlit beaches where each new generation begins. There are 7 living species of sea turtle: the green, the loggerhead, the hawksbill, the olive ridley, the Kemp's ridley, the flatback, and the leatherback. Each is shaped by a slightly different sea, each carries its own quiet history. Tonight we will meet all of them, with no urgency, no demand on your attention. Sea turtles are reptiles, but they have spent so long in the ocean that they have become something almost separate. Their front limbs are long flippers perfectly tuned to fly through water. Their lungs can hold a single breath for hours. Their bodies remember a slower rhythm, the rhythm of a creature that does not need to hurry. If your mind drifts during this video, that is welcome. The voice will keep going, the ocean will keep moving in its gentle tides, and the turtles will keep being patient. You can fall asleep early. You can stay awake and watch. There is no wrong way to be here tonight. Let yourself settle in. Soften your breathing. We are going to drift outward, away from the bright world, into the warm, patient blue, where the great sea turtles are already moving slowly, exactly as they have moved for 100 million years. To know a sea turtle, you must first understand that it is a reptile. It has scales, it lays eggs, its body temperature follows the temperature of the water around it. Yet, unlike most reptiles, the sea turtle has built a life entirely in the ocean. It is in many ways a creature of 2 worlds, born on land, lived in water. The shell of a sea turtle is not a separate piece of armor. It is fused to its spine and ribs, a true part of the body. It cannot pull its head and limbs inside the way pond turtles do. The shell is simply the shape it travels in, light enough to swim with, strong enough to last decades, designed for water rather than land. Sea turtles breathe air like every reptile. They must surface, sometimes after long dives, to fill their lungs again. Yet in the slow lives they live, this surfacing is rare. A resting sea turtle may rise only every several hours. A diving sea turtle may stay below for far longer than that, holding a single breath through journey after journey. Their lungs are different from ours. Sea turtles can collapse their lungs during deep dives, pushing air into a less compressible space, and continue absorbing oxygen from blood and tissue. They can slow their heart rate dramatically, sometimes down to a single beat every several minutes. The whole body learns to wait, while the dive unfolds in patient blue. Their eyes are dark and large, adapted for the soft light of underwater. On land, they look almost teary because they are constantly secreting salt through specialized glands behind their eyes. The salt of the sea is constantly entering them, and their bodies are constantly removing it. The tears are not sadness. They are simply biology working through a quiet exchange.
Sea turtles have no teeth. Instead, the inner edges of their jaws are shaped, sometimes serrated, sometimes ridged, sometimes nearly flat, depending on what each species eats. A green turtle's jaw is built like a vegetable cutter. A leatherback's throat is lined with backward-pointing spines that hold slippery jellyfish in place, gently and without effort.
The flippers of a sea turtle are not paddles. They are long, hydrodynamic wings that beat through water the way a bird's wings beat through air. Watching a turtle swim is watching slow flight. They glide with a kind of patience that no land creature has because they have nowhere they need to rush to. The water itself supports them, and so they float. Their sense of smell is extraordinary. A sea turtle can detect the scent of its home beach from many kilometers offshore. It is thought that this is partly how females find their way back after years of wandering to the very stretch of sand where they themselves were hatched. The ocean is full of subtle chemistry, and turtles read it slowly, patiently, accurately. Sea turtles also use the Earth's magnetic field. Every region of the ocean has a slightly different magnetic signature, a kind of invisible map. Turtles, even tiny hatchlings, can read this map. Their bodies remember where they came from, written in directions and angles in something almost like a sense we do not have. The skin of a sea turtle is tough, scaled in places and smooth in others. It can survive the rough barnacle-encrusted lives of the open sea. Sometimes a turtle's shell becomes its own small ecosystem, barnacles, algae, even small fish that follow it for protection. A single turtle can carry an entire community across the ocean. Their hearts beat slowly. Their muscles work patiently. Their bones grow rings, like the rings inside an old tree, recording each year of life. A sea turtle is not a fast creature. It is a steady creature. It has learned over a very long time that endurance always defeats speed in the open sea. The body of a sea turtle is shaped by the water it has spent its life inside. Streamlined, salt-tolerant, slow-burning. Even the way it sleeps is different from us. Turtles can rest with one eye open, one half of the brain still alert, watching the dim shapes of the deep for any reason to move. Most sea turtles have a hard, bony shell, a carapace built from fused bone plates covered in keratin scutes. The leatherback is the exception. Its shell is leathery, almost rubbery, supported by a flexible mosaic of small bones inside. This unusual shape lets the leatherback dive deeper than any other turtle into pressures that would crush a bony shell. In cold water, sea turtles do something remarkable. Their large body mass and slow metabolism let them keep some heat inside, almost like a long thermal battery. Leatherbacks especially can stay warmer than the sea around them by nearly 10 degrees, an adaptation called regional endothermy. They are not warm-blooded exactly, but they are not cold either. Counter-current heat exchangers run through their flippers. Warm blood leaving the heart heats, the cooler blood returning from the flipper tips. Almost no heat is lost to the surrounding water. The body conserves what it has. Even in subarctic seas, a leatherback's core remains stable enough to keep it moving forward slowly for hours and hours. Their immune systems are surprising. Sea turtles routinely encounter parasites, bacterial infections, and toxins from their food, Yet they often live for many decades. Their wound healing is unusually effective. Bites and small injuries close quietly. The body has evolved to keep going in the salt water despite all the small daily damages. Their vision underwater is excellent. Turtle eyes can see ultraviolet light, useful for picking out prey against bright surface waters. They also detect polarized light, which helps them locate the sun even on cloudy days. The sky becomes a navigation tool even when the sky is hidden behind dense layers of cloud. On land, their vision is poorer. Their eyes are slightly out of focus in air. This is one reason why females nesting on beaches sometimes appear clumsy. They are simply seeing the world in a softer, blurrier way. The land is not really their home. The land is only a place they visit briefly to lay their eggs. A sea turtle's heart has 3 chambers like most reptiles. Slower than a mammal's, it pumps with patience. During deep dives, it slows further, sometimes to 1 beat every few minutes. The blood is shunted away from non-essential organs and toward the brain. The body's economy reorganizes itself for the dive, then quietly reverses on the way up. The skull of a sea turtle is shaped for streamlined motion. The neck cannot pull the head fully into the shell, but the head itself is small and hydrodynamic. The jaw muscles are powerful in some species, soft in others, depending entirely on diet. The whole skull is a slow record of what the species has chosen to eat. Sea turtles have a slow but functional sense of pain. They feel injuries, they retreat from threats, but their pain response is muted in the way that a long-lived, slow metabolism animal's response often is. They tolerate damage that would overwhelm faster creatures. Healing happens quietly without the urgent panic of mammal. In cooler seasons, some sea turtles enter a state called brumation, a kind of slow torpor. They sink to the bottom of cool bays, breathe rarely, and wait out the cold months. Their metabolism drops. Their hearts beat once or twice a minute. They become almost still, almost stopped until the water warms again. Their bones are dense and slightly heavier than seawater. This negative buoyancy helps them stay submerged without effort. To rise, they paddle gently. To sink, they simply stop paddling and let the body settle. Floating for a sea turtle is something they choose. They rarely do it for long. So when you see a sea turtle, you are seeing something built almost entirely by patience, by time, by a body that has been refined generation after generation until every part of it is suited to a slow, ancient, salty existence. There is no waste in a sea turtle. There is only what works for the long journey. This is what a sea turtle truly is. Not just an animal in the sea, but a slow record of 110 million years of small decisions, each one quietly successful, each one passed forward into the next generation. It is one of the patient experiments of the world, and it is still going on tonight. There are 7 species of sea turtle alive in the world today. Tonight we will meet each of them, slowly with no rush. They share the same ancient ancestor, but each has settled into a slightly different part of the ocean, into a slightly different kind of life. Each is its own quiet expression of the same long lineage. The first is the green sea turtle. Its name does not come from the color of its shell, which is usually brown or olive on the outside. It comes from the green color of its body fat, which it gets from a lifetime of eating seagrasses and algae. The green turtle is one of the only large herbivores of the open sea. Greens are large, calm, and widespread. They live in warm coastal waters across the world, sometimes returning to the same patch of seagrass meadow year after year. Old greens can weigh more than 150 kilograms, about the weight of a small couch, and still move with the slow grace of something that has nowhere urgent to go. The second species is the loggerhead. Its head is large and powerful, with thick jaws built to crush hard-shelled prey, crabs, conchs, sea urchins, and even the occasional jellyfish. The loggerhead is named for that head, a heavy, blunt, slightly stern shape that gives the turtle its calm, unhurried look. Loggerheads are champion travelers. Some individuals cross entire ocean basins in a single lifetime. A loggerhead hatchling born on a beach in Japan may grow up off the coast of Mexico, then return to that same Japanese beach decades later to nest. The map they carry is enormous, and they trace it with an unhurried, steady patience. The third species is the hawksbill. Its name comes from its narrow, beak-like jaw, perfectly shaped for reaching into coral crevices. The hawksbill eats sponges, sometimes the very kinds that are toxic to other animals. Over time, its body has learned to neutralize those toxins and keep eating quietly, year after year. Hawksbills are the most colorful of the sea turtles. Their shells are patterned with golden brown and reddish scutes, almost glass-like when polished. Sadly, this beauty is one of the reasons their numbers have suffered for centuries. Their shells were once turned into combs and jewelry. Today, hawksbills are critically endangered, slowly returning under careful protection. The fourth species is the olive ridley, named for the olive-green color of its shell. Olive ridleys are smaller than greens or loggerheads, but they are famous for one of the most extraordinary events in the natural world, the arrabada, a Spanish word meaning arrival. They come ashore not one by one, but in great gatherings as if at a quiet appointment. During an arrabada, tens of thousands of female olive ridleys come ashore on a single beach, all on the same handful of nights to lay their eggs together. The beach fills with turtles, slowly all night, all moving together. It is one of the most synchronized events in the ocean, and no one fully knows how they coordinate it. The fifth species is the Kemp's ridley. It is the smallest sea turtle in the world, and it has the smallest range, nesting almost exclusively on a stretch of coast in the Gulf of Mexico. For decades, the Kemp's ridley was thought to be heading toward extinction. Conservation efforts have slowly started to pull it back, year by patient year. Like olive ridleys, Kemp's ridleys also have arrabadas, though much smaller now than they once were. Each year, a fragile, growing number of Kemp's ridley females return to nest. Each successful nest is a small repair to a long history of damage. Each surviving hatchling is a small piece of a very slow recovery written in quiet sand. The sixth species is the flatback. It lives only in the shallow seas around Australia, never venturing into the open ocean the way other sea turtles do. Its shell is unusually flat, more like a dinner plate than a dome. Its life is quieter, more local, less dramatic. The flatback simply stays close to home generation after generation. Flatbacks are perhaps the least studied of the sea turtles, partly because they live in fewer places, partly because they are not as long distance as the others. But every species has its own quiet contribution to the ocean. The flatback's contribution is to keep being exactly itself in exactly its small piece of the world. The seventh and largest species is the leatherback. The leatherback is unlike any other sea turtle alive. Its shell is not bony, it is leathery, made of skin over a flexible cartilage frame. It can dive deeper than any other turtle, deeper than most whales. It can be found in colder seas, far from the tropics. A leatherback can weigh more than half a ton. Its diet is almost entirely jellyfish, strange, soft, mostly water, and it must eat enormous quantities to stay alive. A single leatherback may consume hundreds of jellyfish in a single day, drifting from cluster to cluster, eating slowly through bloom after bloom. These 7 species evolved over the last 50 million years. Their fossil ancestors include even more species, some larger than any sea turtle alive today. The biggest known prehistoric sea turtle, called Archelon, lived around 80 million years ago, was 4 meters long, and weighed more than 2 tons. The seas were vaster then, and so were the turtles. Why only 7 species today? Because extinction has worked patiently in the background of every long lineage. Many sea turtle species existed before, relatives of greens, of leatherbacks, of forms we have no modern analog for. They came, they survived, they faded. The 7 we have now are the ones still finding it possible to keep going. Geographically, the species overlap in many places. Off the coasts of Costa Rica, you can find greens, leatherbacks, hawksbills, and olive ridleys, all using the same waters at different depths. Each follows its own niche. Each rarely interferes with the others. The ocean is large enough that several species can patiently coexist. Hybrids occasionally occur. A green and a hawksbill, both nesting on the same beach in the same season, sometimes produce mixed offspring. The genetic boundaries are real but not absolute. Sea turtles, like many ancient lineages, retain some flexibility, small bridges between species that science is still mapping. The current conservation status of the 7 species is sobering. The IUCN lists hawksbills as critically endangered, Kemp's ridleys as critically endangered, leatherbacks as vulnerable, greens as endangered, loggerheads as vulnerable. Olive ridleys and flatbacks have less precise classifications, but face their own pressures. None are safe, all are watched. Together, these 7 species cover nearly every warm and temperate ocean on Earth. Greens in the seagrass beds, loggerheads on long crossings, hawksbills in the reefs, olive ridleys in great gatherings, Kemp's ridleys in the Gulf, flatbacks near Australia, leatherbacks in the deep cold, each one a small calm presence in a very large sea. They have shared the planet with us for the entirety of our species. They were swimming in these same waters when our ancestors first walked out of Africa. They were ancient already. They still are. Tonight, every one of these 7 species is somewhere in the ocean, doing exactly what it has always done. And in some quiet sense, the survival of the 7 living species depends on each other. Greens keep seagrass meadows healthy, which support fish populations that feed loggerheads. Hawksbills clean coral reefs, which shelter young of every species. The 7 are not just 7 separate stories, they are pieces of a single, slow, salty system. So when you imagine sea turtles, do not imagine just one. Imagine the 7 scattered across every warm sea, each living its own slightly different version of the same patient life, each shaped by where it ended up, each even now gliding quietly through the night water, exactly as it always has. Watching a sea turtle swim is watching slow flight. Their long front flippers do not paddle the way fish fins do. They beat up and down, exactly the way a bird's wings beat through air. Each stroke is unhurried. Each stroke moves the body forward by almost a full body length, and then the next stroke begins. This wing-like motion has a name in biology: aquatic flight. Only a handful of marine animals use it. Sea turtles, penguins, sea lions, and a few extinct creatures. The rest of the ocean swimmers, fish, sharks, dolphins, use side-to-side body motion instead. The turtle is a flyer, not a swimmer in the technical sense. The rear flippers are different. They are smaller, blunter, and more like rudders. They do not generate much forward motion. They steer. They tip the body left or right, up or down. They allow the turtle to make precise small adjustments while the front flippers carry on with their slow, rhythmic flight. The body shape itself is hydrodynamic. The shell is rounded but flattened on top, pointed at the front, tapered toward the back. Water flows over it the way air flows over an aircraft wing. This shape is not random. It is the result of 100 million years of selection, refining each generation slightly closer to perfect glide. A leatherback's shell has 7 raised ridges running from front to back. These ridges are not just decorative. They reduce drag in the water by guiding flow smoothly along the body. They turn what would be a flat shape into a subtly fluted form. The turtle moves through the sea more easily because of these gentle ridges. Most sea turtles cruise at 1 to 2 kilometers per hour. They could go faster. Burst speeds of around 30 kilometers per hour are possible, but they almost never do. The cost of speed is enormous. The cost of slowness is small, so the turtle, generation after generation, simply stays slow. Their breathing is patient. Even at the surface, a sea turtle does not gulp in many breaths. 1 or 2 slow exhalations followed by a long inhalation, and the turtle dips back below. The whole exchange takes only a few seconds. Most of the rest of life is spent without thinking about breath at all. Diving is where the body becomes most remarkable. As the turtle descends, the lungs collapse to take pressure off the body. Oxygen reserves move into the bloodstream. The heart slows from 40 beats per minute down to 1 or 2. The animal becomes a quiet, oxygen-conserving submarine, equipped for the long stretch of darkness ahead. Leatherbacks dive the deepest of all. They have been recorded reaching 1,200 meters below the surface. The water at that depth is cold, dark, and crushing. Almost no creature visits these zones. The leatherback does, almost casually, in pursuit of jellyfish that follow the deep scattering layer. Smaller species do not dive nearly as deep. Greens and hawksbills usually stay within 20 or 30 meters of the surface. Loggerheads can reach a few hundred meters during longer foraging dives, but they prefer the warmer upper layers. Each species has settled into the depth that suits its food and its physiology. Their flippers are also tools on land. Briefly, when a female sea turtle climbs the beach to nest, she uses her front flippers as awkward levers, dragging her enormous body across the sand. It is the slowest, hardest part of her year. The flippers were not made for sand. They tolerate it for an hour and then return to water. Their bodies are built around buoyancy management. The lungs, when full, give the turtle slight positive buoyancy. The bones and shell, dense and heavy, give slight negative buoyancy. By controlling the air in the lungs, the turtle can balance its position in the water column, hovering motionless if it chooses, or sinking slowly into a chosen depth. They have an unusual swimming gait at very low speeds. When a turtle is barely moving, its flippers trace gentle figure-8 patterns. This pattern lets it generate very small amounts of lift in any direction, allowing micro-adjustments without committing to a real stroke. It is the swimming equivalent of slow walking. In currents, sea turtles often choose to ride rather than fight. They angle their bodies into the flow, let the water carry them, and steer rather than swim. This conserves enormous amounts of energy. A turtle in the right current can cover hundreds of kilometers without significant muscular effort, simply by floating in the right direction. They feel pressure changes through their bodies. The shells contain mechanoreceptors, small sensory cells that detect subtle shifts in water pressure, equivalent to feeling depth changes through their skin. They know how deep they are without needing to look. The dive is mapped from the inside. They sense vibration, distant predators, distant boats, distant approaching storms. All of these create slight vibrations in the water that the turtle's body can detect. They cannot react quickly the way a fish can, but they often have enough warning to choose a quieter path. The information arrives slowly, but it arrives. Their salt glands work continuously. With every minute they are alive, the turtle's body absorbs some seawater. With every minute, the salt glands behind the eyes secrete the excess back out. It is a slow, salty rhythm, taking in, releasing, that runs alongside the breath, the heartbeat, the slow blink of the dark eye. On long migrations, their swimming becomes almost mechanical. Days of steady stroking, no decisions, no urgency, just the slow, patient covering of distance. The turtle sleeps as it swims in short fragments. The body keeps moving on autopilot. Distance accumulates without thought. Their eyes adjust constantly. Underwater, the lens shape compensates for the way water bends light. At the surface, the same eyes work less well, slightly out of focus in air. The turtle accepts both. The world above the water is briefly necessary. The world below the water is home. Their inner ears are simple but functional. They hear low frequencies well, the rumble of distant breaking waves, the vibration of a passing whale. Higher frequencies are muffled. The acoustic world of a sea turtle is bass-heavy, slow and patient, suited to the long, unhurried life it lives. After a long dive, surfacing is a deliberate act. The turtle angles its head upward and rises slowly, often using a spiral path so it can scan the surface for danger before breaking through. When the head emerges, the breath is taken almost calmly. There is no panic. There is only slow, completed need. They clean themselves at reef stations. Small fish like wrasses and surgeonfish have learned that turtles will pause and allow themselves to be cleaned of algae and parasites. The turtle hovers patiently, the small fish work. It is one of the gentle, quiet collaborations of the warm sea. Resting, sea turtles wedge themselves into cracks in coral or sit motionless on the seafloor. With their slow metabolism, they can stay in place for hours, breathing only occasionally. The body becomes part of the structure around it. Photographers sometimes swim past resting turtles without noticing them at all. Their movement vocabulary is small but complete. Glide, descend, ascend, hover, rest, turn surface, breathe, dive again. Almost every action a sea turtle takes belongs to one of these patterns. The simplicity is part of why they last. There is no wasted motion in a creature that has been refining its motion for 100 million years. And so the body of a sea turtle becomes a kind of slow lesson about patience built into anatomy, about efficiency hidden in shape, about the long, quiet conversation between an animal and the medium it lives in. The turtle is not just moving through water, the water is moving through the turtle slowly, gently for an entire life. Every sea turtle alive today began the same way, as an egg, soft-shelled and small, buried in warm sand on a quiet stretch of beach. It is a beginning that almost no human will ever witness, because it happens in the dark deep beneath the surface, in the patient breathing of warm grains. A female sea turtle digs her nest with her back flippers, slowly, methodically, sometimes for an hour or more. The hole is shaped like a flask, narrow at the top, wider at the bottom, deep enough to keep the eggs at a stable temperature. When the chamber is ready, she settles over it and begins to lay. She lays 100 to 200 eggs in a single nest, sometimes more. The eggs are round and white, the size of small ping-pong balls. She covers them carefully, smooths the sand, and returns to the sea. She will not see her young hatch. By the time they emerge, she will be far away, possibly nesting again somewhere else. The eggs are soft-shelled, almost leathery. Unlike chicken eggs, they cannot crack from gentle pressure. They flex. The shell allows water to slowly enter and gases to slowly exchange. Inside, the embryo grows surrounded by a small private ocean of yolk and fluid, kept stable by the steady warmth of the sand around it. The eggs incubate beneath the sand for about 2 months. The temperature of the sand quietly determines what the hatchlings will become. Warmer sand produces females, cooler sand produces males. This is called temperature-dependent sex determination, and it is something most reptiles have always done. Inside each egg, a small turtle is forming. Tiny flippers begin to move, a small heart begins to beat. The yolk slowly becomes a body. The egg is the first ocean, a private, warm, salty space that contains everything the small turtle needs until it is ready to break free. Embryonic development passes through quiet stages. First, the body axis, then the limb buds, then the shell rudiments forming under the skin. By halfway through incubation, the small turtle inside the egg is recognizably itself, a tiny, curled, soft-shelled version of what it will become. It begins to move very slightly. Not every egg makes it. The temperature of the sand may rise too high, drowning the embryo in heat. The sand may be invaded by a fungus or by tiny, burrowing predators. The beach may flood from a high tide. A nest that begins with 200 eggs may produce only 150 viable hatchlings, sometimes fewer. When the time is right, the hatchlings begin to break through their shells with a small bump on their snout called an egg tooth. They emerge from the eggs but do not leave the nest immediately. They wait sometimes for several days listening while the others catch up. Sea turtles are born together. They prefer to leave together. Inside the nest, the hatchlings begin a quiet conversation with each other. Soft clicks, tiny vibrations. As more hatchlings emerge from their eggs, the chorus grows. The sound seems to coordinate them. They sense each other's readiness. They wait until the group is ready to climb upward together as one slow rising tide. Then, almost always at night, when the sand has cooled and the predators have grown drowsy, the hatchlings climb upward through the sand together. It is a slow, quiet, methodical climb. Their soft shells press against the loose grains. They surface as a small group, sometimes more than 100 tiny lives, all at once. On the surface, they pause. They orient themselves. The brightest horizon almost always is the moonlight reflecting off the ocean. They turn toward it, and they begin to crawl. They have never seen the sea before. They are following light. They are following something written into them by 100 million years of evolution. This crawl is the first dangerous moment in their lives. Crabs wait. Birds wait. The beach is uneven. Each hatchling is barely the size of a person's palm, with no shell strong enough to survive a single bite. They move fast, faster than they ever will again toward the water. Predators have learned the rhythm of nesting beaches. Ghost crabs emerge from their burrows when they sense the hatchlings climbing. Frigate birds and gulls patrol the air. Foxes, raccoons, mongooses, depending on the country, gather at the edge. The hatchlings run a gauntlet. Most of them survive, many do not. Most of them make it to the water. Many do not. Then, in the water, the second danger begins. Fish wait. Larger fish wait. The hatchlings begin a swim that will not stop for many days. They swim from the shore outward, paddling endlessly, eyes wide, into the open ocean. This first swim has a name. Biologists call it the swimming frenzy. The hatchlings paddle for almost a full day without stopping, fueled only by the yolk reserves still in their bellies, racing to reach the deeper, safer open ocean before they exhaust themselves or are caught. It is the most intense effort of their entire lives. Once they reach the open sea, the hatchlings disappear. For years, sometimes decades, almost no one knows where the small turtles go. Biologists call this period the lost years. The young turtles drift on currents, hide in floating mats of seaweed, eat tiny prey, and grow slowly out of sight. They live in a moving world. The Sargasso Sea, the great gyres of the Pacific, the slow currents of the Atlantic, these are the nurseries. Floating sargassum and other seaweed forms small islands. Tiny invertebrates cling to it. Tiny turtles cling among them, almost invisible, riding the currents in safety. Their first food is whatever the seaweed island provides. Small crustaceans, tiny jellyfish, floating eggs of fish and squid. The hatchlings nibble carefully, conserving their growing energy. Their shells slowly harden, their flippers slowly strengthen. The body that began in a sand chamber learns the open ocean from the inside out. Of every 100 hatchlings that crawl into the sea, only a handful will live to adulthood. Estimates vary. Some say 1 in 1,000, some 1 in 10,000. The numbers are sobering, but they are also why female turtles lay so many eggs. The species depends on enough small lives surviving to keep the patient lineage going. As the surviving hatchlings grow, they slowly leave the seaweed islands and venture into the open water. Their shells become bony enough to deter most predators. Their swimming becomes confident. The lost years end gradually, sometimes after a decade, sometimes longer. They become juveniles. They become noticeable to scientists again. They begin to seek the foraging grounds where they will spend much of their adult lives. A green turtle finds the seagrass meadows. A loggerhead finds the rocky reefs. A hawksbill finds the coral banks. Each turtle quietly settles into a habitat that matches its species, often hundreds of kilometers from where it was born. They will live in these foraging grounds for years, sometimes decades, growing toward maturity. A green sea turtle does not become reproductively active until her 20s or 30s. The slow life requires a slow childhood. Time is not wasted in this development, it is necessary. And so, somewhere tonight, a hatchling is breaking out of its egg. Somewhere else, a small group is climbing toward moonlight on a beach you will never see. Somewhere, in a wide, warm sea, a slightly older juvenile is hiding inside a piece of floating seaweed, drifting toward whatever ocean it will spend the next decade growing in. The journey of a hatchling is the slowest, longest journey in the natural world. It begins in a warm nest. It passes through a frenzied swim. It hides in the open sea for years. It quietly grows, and eventually, after a decade or 2 or 3, the small turtle becomes a full sea turtle ready to return. Each species of sea turtle has built itself around what it eats. Greens, loggerheads, hawksbills, leatherbacks, ridleys, flatbacks. The body of each one is a slow record of what its ancestors found, generation after generation, in the warm and cool seas of the world. The green sea turtle is the only large herbivore among them. Its diet is mostly seagrass and algae, slow-growing plants that carpet shallow tropical waters. To eat them, the green turtle has developed a finely serrated jaw, like a small set of garden scissors that snips off blades of grass without uprooting them. Seagrass meadows are some of the most important and most overlooked ecosystems on Earth. They store enormous amounts of carbon, they shelter young fish, and they feed sea turtles. A green sea turtle that has lived for many years in the same meadow becomes a small, slow gardener, keeping the grasses cropped, fertilized, and healthy. By cropping seagrass blades, greens stimulate new growth. They also shed nutrients into the meadow through their movements and waste, fertilizing the plants they live among. Without sea turtles, many seagrass meadows become overgrown and choked. With them, the meadows stay open, productive, and full of life. The grazing helps everyone. Hawksbills do not graze. They reach. Their narrow beak-like jaw is built for slipping into the cracks and crevices of coral reefs and pulling out sponges. Sponges are not easy to eat. Many of them contain glass-like spicules. Others contain toxic chemicals that they manufacture as a defense. The hawksbill quietly works around all of this. Hawksbills have developed enzymes that neutralize sponge toxins. Over millions of years, their digestive systems have learned to break down materials that would poison other animals. By eating sponges, they keep coral reefs from being smothered by overgrowing sponge populations. They are, in a quiet way, reef gardeners. Loggerheads are powerful eaters. Their jaws can crush the hard shells of crabs, snails, conchs, and even the spines of sea urchins. A loggerhead spends part of its life patrolling the sandy seafloor, head close to the substrate, looking for the small movements that mean shellfish hidden just below the surface. A loggerhead's bite force is one of the strongest in the reptile world. They can crack the shell of a horseshoe crab. They can break open a queen conch. The thick, crushing surfaces of their jaws have evolved over tens of millions of years to handle exactly the prey items the species depends on. Leatherbacks are the strangest eaters of all. They eat almost nothing but jellyfish, soft, gelatinous, mostly water. To survive on a diet that is 90% water, a leatherback must eat enormous quantities. A single leatherback may consume its own body weight in jellyfish every 2 or 3 days, drifting from cluster to cluster. To hold those slippery jellyfish in place, The leatherback's throat is lined with backward-pointing spines, almost like the inside of a thorn bush. Anything that goes in cannot easily slip out. The spines are made of soft tissue, but they hold their shape long enough to send each meal slowly downward into the patient's stomach. Olive ridleys and Kemp's ridleys are omnivores. They eat what they can find: small crabs, shrimp, jellyfish, fish, occasionally seagrass. Their flexibility is part of why they can survive in disturbed environments where the more specialized turtles struggle. They are quiet generalists in a sea of specialists. Flatbacks live close to the Australian coast and eat soft-bodied prey, sea cucumbers, soft corals, jellyfish, sometimes shellfish. They never venture far into the open ocean, so their entire feeding life unfolds within a few hundred kilometers of where they were born. It is a smaller life, but no less complete. Eating in the salt sea is not easy. Salt water is constantly entering the bodies of these reptiles, and they must constantly remove it. Behind their eyes, sea turtles have specialized salt glands, small organs that secrete the excess salt back out. When a sea turtle on land seems to be crying, it is actually balancing its body chemistry. They drink almost no fresh water. Almost everything they need they extract from their food and from the seawater itself. Their bodies have become very efficient at this. A sea turtle can spend its entire life surrounded by water and remain almost perfectly hydrated, removing the salt as patiently as it accumulates. Sea turtles do not eat constantly. Their metabolism is slow. A leatherback may not eat for days during a long migration. A loggerhead may rest for hours after a single large meal. They live closer to the rhythm of plants than the rhythm of mammals, long, patient cycles of feeding, digesting, and waiting. A leatherback's energetic needs are enormous despite its slow pace. It must consume between 200 and 300 kilograms of jellyfish per day during peak feeding. Its body has become a slow machine for moving from jellyfish bloom to jellyfish bloom, finding the next cluster, eating it down, moving onward. Jellyfish blooms are unpredictable. Some years there are many, some years there are few. Climate change is shifting these patterns, sometimes creating more blooms than ever, sometimes scattering them in new locations. The leatherback's body is built around following them, generation after generation, wherever they go. Cleaning stations on coral reefs offer a different kind of meal, not for the turtle but for the small fish that gather. Wrasses, surgeonfish, and butterfly fish remove algae and parasites from the turtle's shell. The turtle hovers patiently while small mouths work over its surface, a quiet exchange that benefits everyone. Some turtles develop personal foraging routes, returning to the same coral heads, the same seagrass patches, the same sandy depressions week after week, year after year. A turtle's home range is not just where it eats, it is where it remembers eating, where it has built up small mental maps of food and rest. Greens digest their plant food slowly, producing methane in the process. Studies suggest that the world's sea turtles produce a small but real amount of greenhouse gas through this digestion. It is a tiny contribution compared to industrial sources, but it is part of the slow chemical breath of the ocean ecosystem. And in the slow eating of jellyfish, of seagrasses, of sponges, of crabs, the sea turtles quietly shape the oceans they live in. They keep seagrass meadows healthy, they keep coral reefs cleaner, they keep jellyfish populations in check. They are not just eaters, they are caretakers in their own slow, salty way. Tonight, Somewhere in a warm, shallow bay, a green turtle is grazing on seagrass that will be a little better for having been trimmed. Somewhere in deeper water, a leatherback is eating a slow procession of jellyfish. The patient feeding of the sea turtles is one of the quiet currents that hold the ocean together. None of this eating is hurried, none of it is greedy, none of it is wasteful. The turtle eats what it needs, what its body has learned to use, and then rests. The slow appetite of a sea turtle is one of the gentle realities of the warm ocean. It teaches that survival does not require speed, it only requires consistency. Most sea turtles do not stay where they hatch. They are born on a beach, swim into the open sea, and over the following years and decades they travel, sometimes across entire oceans. Migration is one of the central facts of their lives. They are slow, but they are very, very steady. A loggerhead hatchling born on a beach in Florida may drift on currents into the Sargasso Sea, then into the North Atlantic Gyre, eventually arriving in the seas off the Azores. There it grows. After many years, it begins to swim back slowly until it returns to the same beach where it began. The trip can be longer than 10,000 kilometers. Some loggerhead populations cross the entire Pacific. Hatchlings born on Japanese beaches drift east on the Kuroshio Current. They grow up off the coasts of Mexico and California. Then, decades later, they swim all the way back across the Pacific Ocean, 8,000 kilometers, sometimes more, to nest on the same beaches where they hatched. Leatherbacks make some of the longest migrations of any animal. A single leatherback may travel 16,000 kilometers in a single year, following jellyfish blooms across hemispheres. They cross from cold subarctic seas to warm tropical breeding grounds, year after year, on a body shaped almost entirely for this kind of journey. How do they navigate? Partly by the sun, partly by ocean currents, partly by smell, but mostly, scientists believe, by the Earth's magnetic field. The planet has a slowly varying magnetic signature, with the angle of the field lines and the strength of the field both changing across the surface. Every patch of ocean has its own magnetic address. Sea turtles can read this address. Their bodies contain tiny magnetic particles, and somehow, in ways that science is still working to understand, they can sense both the angle and the intensity of the field. A turtle can know, in a sense, exactly where on the planet it is, even thousands of kilometers from any landmark. This magnetic sense is present even in hatchlings. A tiny sea turtle, hours old, will swim in a particular direction based on the magnetic field around it. If you change the field, experimentally, the turtle will turn. They are born already mapped. They are born already pointed at the right ocean. The phenomenon of returning to the same beach you hatched on is called natal homing. It is found in salmon, in some seabirds, and most powerfully in sea turtles. A female may not return to her natal beach for 30 years. When she does, she finds it again with extraordinary precision, sometimes within a few hundred meters. Why do they go back? Why don't they simply nest on the closest beach to wherever they happen to be? The answer is partly genetic. Natal homing is hardwired and partly ecological. The beach where you were born is, by definition, a beach where sea turtles can successfully hatch. It has been proven. It is reliable. Loggerheads can hold migration paths so consistent that researchers can identify which beach a juvenile is from based on its genetic signature alone. Each population has its own line on the map, Each turtle inherits the path. Each generation maintains the lineage of the route, like a slowly redrawn map kept faithful by the species. Migration is rarely fast. A sea turtle moves at 1 or 2 kilometers an hour, sometimes faster on currents, sometimes slower against them. The journeys take months, they take years. There is no urgency built into the body. The turtle simply keeps going in the right direction until it arrives. Along the way, they encounter currents that help and currents that hinder. They encounter storms. They encounter long stretches of empty water where there is nothing to eat for many days. Their slow metabolism is part of why they survive these stretches. They simply burn fuel patiently and keep moving. Some migrations take turtles into colder water than people would expect. Leatherbacks have been spotted off the coasts of Norway, Iceland, even off Newfoundland. They cannot truly thermoregulate, but their large body mass holds heat surprisingly well, and their thick blood vessels keep their cores slightly warmer than the surrounding sea. Migrations follow seasonal rhythms. Foraging grounds are often hundreds or thousands of kilometers from nesting beaches. The turtle spends most of the year feeding, building up the reserves needed for reproduction, and then makes the long swim home only when ready. The whole life is choreographed by these alternating seasons of growth and journey. Why do migration paths exist at all, in evolutionary terms? Because the best places to feed are not always the best places to nest. Cold, productive seas are rich in jellyfish. Warm tropical beaches are safe for eggs. The turtle's body has had to learn to live in two worlds, and migration is the slow bridge between them. Energy cost of migration is a balancing act. Each kilometer of swimming costs calories. Each delay invites predators. The turtle's body has been refined to spend just enough effort, take just enough time, and arrive with enough reserves left to reproduce. Generation after generation, the route has been optimized by quiet attrition. During migration, females often do not eat. They rely on fat reserves built up at the foraging grounds. By the time they reach the nesting beach, they have lost a noticeable percentage of their body weight. After laying eggs, they begin the slow journey back, still mostly fasting, slowly refilling their reserves only after they reach home. Males also migrate, although less is known about their patterns. They tend to follow females toward the breeding grounds and may mate offshore before females climb the beach. Male migrations are usually shorter than female migrations, but they are still significant, hundreds of kilometers in many populations. Hatchlings, drifting on currents, follow a passive form of migration. They do not actively swim across oceans, they ride. The North Atlantic gyre carries Florida hatchlings around in a slow circle that takes years to complete. By the time they leave the gyre, they have grown enough to swim purposefully on their own. Adult migrations, by contrast, are active. The turtle holds a magnetic heading. The body keeps stroking. The flippers beat slowly through water hour after hour. Even at 1 kilometer per hour, 20 hours of swimming covers 20 kilometers, and 20 days of swimming covers 400. The arithmetic of slowness becomes large. Some turtles migrate every 2 or 3 years, others migrate every year. Reproductive timing varies by species, by population, even by individual. A green sea turtle may nest 1 year, skip 2, then nest again. Her body decides based on her food availability, her age, and the slow rhythms of her own physiology. Researchers track migrations using satellite tags. The data has revealed routes that were invisible before, Loggerheads from Florida sometimes detour through the Gulf Stream rather than crossing it. Leatherbacks from California travel to specific feeding zones off Indonesia. The slow travel paths of sea turtles have become visible at last. And so, while you are here listening, somewhere in the world a sea turtle is in the middle of a journey. It may have traveled 300 kilometers in the last week. It may be reading a magnetic field that you and I cannot feel. It will keep going for as long as it needs to. The migration does not end until it ends. Migration is the slow architecture of a sea turtle's life. Without it, the species could not exist. With it, the same beach where one female was born receives her again decades later, ready to lay her own eggs in the same patient sand. The map is invisible, but it is faithful and it is older than language. Sea turtles are not fast. They are not flashy. They do not roar or sing or display in dramatic ways. What they have instead is patience and the kind of slow knowledge that only comes from a body designed to last a very long time. To watch a sea turtle is to watch slowness as a form of intelligence. They live a long time. A green sea turtle can live more than 70 years in the wild. Loggerheads live similarly long. Some scientists suspect that leatherbacks may live longer still, though their secretive lives in the open ocean make this hard to confirm. A single sea turtle can outlast many of the people who watch it. During those decades, a sea turtle accumulates experience. It learns the currents, it learns the food locations, it learns the migration routes, it learns the seasonal rhythms of the sea. By middle age, a sea turtle has internalized a kind of map of its world that no human has ever fully decoded. They do not appear to communicate the way social mammals do. There's little vocalization. They do not swim in tight social groups. Each turtle mostly lives alone, and yet they manage year after year to find each other on the right beaches at the right times. The coordination happens without conversation. Their senses are tuned to a slower world. They can see ultraviolet light, helpful for distinguishing some of the tiny prey items in the open ocean. They have a fine sense of smell, both in air and in water, which lets them find food and identify their natal beaches. Their hearing is muted, but they sense vibration and pressure quietly. They feel temperature. Sea turtles are cold-blooded, but they are far more aware of subtle thermal changes than people realize. They follow warm currents in cooler seasons, dive into cooler water during the heat of summer, and use temperature in their nesting decisions. The sand temperature shapes the next generation, and they choose carefully where to dig. Their pace makes them reliable witnesses to the long, slow changes in the ocean. A sea turtle that hatched in 1960 has lived through a doubling of the global human population, through dramatic warming of the seas, through enormous shifts in fish populations. It carries that history quietly inside its body. The shells of sea turtles, like the trunks of trees, can be read for evidence of past environmental conditions. Growth lines, isotope signatures, and small changes in the shell layers all record what the ocean looked like decades ago. A single sea turtle is a swimming archive of climate, food availability, and chemical balance. Their slowness is also a kind of efficiency. By moving slowly, sea turtles burn very little fuel. By eating sometimes and resting often, they maintain themselves at low cost. The trade-off is a long life with low intensity, very different from the high-intensity short lives of fast-moving fish. They sleep in interesting ways. Sea turtles can rest underwater for hours, surfacing only when they need to breathe. Some species wedge themselves into crevices in coral reefs and wait out the night. Others simply hover quietly in the water column, almost motionless, while half of their brain remains alert. Their behavioral repertoire is small but durable. Glide, feed, rest, dive, surface, breathe, navigate, mate, nest. Each behavior is performed thousands of times across a lifetime. Each repetition is slightly informed by experience. By age 40, a sea turtle is a calm specialist in the very specific small set of actions its life requires. They build mental maps of their foraging grounds. A green turtle that has lived for decades in a particular coastal bay knows where every reliable seagrass patch is, where the cleaning stations are, where the safest sleeping crevices wait. This knowledge is not taught, it is accumulated slowly through repeated visits. Decision-making in sea turtles is observable but mysterious. A turtle pauses at a coral junction. It tilts its head. It chooses a path. The choice is consistent. The same turtle often picks the same route on different days. Something internal is at work, something we do not yet have the language to describe. Long-term studies in places like Hawaii have shown that individual sea turtles develop recognizable personalities. Some are bold around researchers, others are shy, some prefer particular cleaning fish, others avoid them. The species is not a uniform set. Each turtle slowly becomes itself. They appear to recognize specific human swimmers. In areas where diverse visit the same reefs over decades, certain turtles seem to tolerate familiar humans more than strangers. Whether this is true recognition or simply habituation is debated, but the slow patience of the turtle includes some kind of memory of who has been around. Trust builds slowly. A new researcher entering a turtle's home range may be avoided for weeks or months. Eventually, the turtle stops fleeing. It tolerates the human presence. It continues feeding nearby. The trust is fragile and real, and it shows that something in the turtle is paying attention, even if quietly. The wisdom of a sea turtle is not the wisdom of a parrot or a chimpanzee. It is not built around problem-solving or tool use or social negotiation. It is built around endurance, around remembering, around moving through the same patient circuits over decades. It is a wisdom of repetition done well. Their aging process is gentle. Older sea turtles do not show the dramatic decline of older mammals. They grow more slowly. Their shells take on patina. They spend more time resting, but they often continue to nest into their 50s, 60s, 70s. The body fades by gradient, not by sudden cliff. The last journey of an old turtle is, like the rest of its life, unhurried. It simply moves a little less. It feeds a little less. One day it does not rise to breathe. The body sinks slowly. The reef where it has lived for decades absorbs it back into the slow cycle of small lives that built it. Maybe the slow wisdom of a sea turtle is something we do not yet know how to measure. We measure speed and intelligence and complexity in ways that match our own minds. Perhaps the long, calm patience of a turtle is a different kind of intelligence, one we have not yet built the right tools to see. Their quiet presence in the ocean is itself a form of expertise. They know where the warm currents run. They know where the jellyfish bloom. They know which beaches still have safe sand. They are, in a sense, ocean readers. Each turtle is a slow consultation between body and sea. Whatever it is, it has worked. It has worked for 110 million years. It has carried sea turtles through extinctions that ended dinosaurs and changed entire continents. While the great fast intelligences of the world rose and fell, the slow patient intelligence of the sea turtle simply kept swimming. Tonight, somewhere in the warm, dark seas, that wisdom is at work. A turtle is choosing where to rest for the night. Another is selecting which jellyfish to eat. Another is reading a magnetic field that points toward a particular distant beach. Each choice is small, slow, considered exactly as it has always been. Sea turtles do not live in one kind of place. They use the ocean in layers, the warm, shallow seagrass beds, the bright coral reefs, the open midwater where currents move them, the deep, cold layers where leatherbacks chase jellyfish. Each species moves between these worlds at different times of life. The coral reefs are perhaps the most familiar home. Greens and hawksbills spend large portions of their lives on or near reefs, grazing, hunting, sleeping in the small protected crevices that the reef provides. A reef is essentially a city, a layered, complex living structure that shelters a vast number of species. Coral reefs are built over thousands of years by colonies of small animals called polyps, each one no larger than a fingernail. These polyps secrete calcium carbonate, slowly building the structure they live inside. A single reef may be hundreds of years old, sometimes thousands. Some are older than the oldest pyramid. For sea turtles, reefs are food, shelter, and information. The intricate structure provides hiding places. The diversity of small invertebrates, sponges, crustaceans, mollusks provides meals. The currents that wind through reefs carry chemical signals that turtles can read. A turtle that knows a reef knows it deeply. Hawksbills in particular are reef specialists. Their narrow beaks are perfect for the kind of intricate foraging that reefs allow. A hawksbill knows which ledges hold sponges, which crevices hide small crabs, which corals will be alive next year and which will not. Its life is woven into the reef itself. Greens use reefs differently. They use the protective edges, but their main feeding grounds are the seagrass meadows that often grow in the shallower water adjacent to reefs. A green turtle's day might involve grazing in the meadows in early morning, then moving to a reef edge to rest through the warmest part of the afternoon. Reef bleaching is one of the new threats. When water temperatures rise, the corals expel the symbiotic algae that give them color and food. The reef turns white. If conditions persist, it dies. Bleached reefs lose their fish. They lose their sponges. The hawksbills who depended on them must travel further and find less. Some reefs recover. The corals slowly regrow. The fish slowly return. The hawksbills slowly come back, but recovery takes years or decades. The slow rhythm of the reef is being tested by the faster rhythm of climate change. The turtles, who measure time in centuries, sometimes find their familiar places already gone. Beyond the reefs lie the seagrass meadows themselves, wide, calm, sunlit underwater plains. Seagrass is one of the few flowering plants that has returned to the ocean. Like all flowering plants, it descends from a land ancestor, and like sea turtles, it has spent millions of years rebuilding itself for life under the sea. In healthy seagrass meadows, you find a quiet richness, small shrimp, baby fish, seahorses, and the slow movement of grazing turtles. The grass softens currents. It traps fine sediments. It produces oxygen. Where seagrass thrives, the entire local ocean is calmer and more productive. Sea turtles help keep these meadows healthy by grazing them open. Sea turtles also use mangrove forests, especially in younger life stages. Mangroves are coastal trees that grow with their roots in salt water, creating tangled, sheltered nurseries beneath their canopies. Juvenile sea turtles sometimes shelter among mangrove roots, hidden from larger predators while they grow. Mangrove root systems trap sediments, build coastlines, and host enormous numbers of small marine creatures. They are in many places the bridge between ocean and land. Young sea turtles passing through mangrove zones encounter their first dense ecosystems after the open ocean drift. The complexity is new, and they slowly learn it. Some species, like leatherbacks, almost never enter shallow water at all. Their world is the open ocean, the great pelagic blue between the continents, where the water is deep and the light fades quickly with depth. Leatherbacks may spend years far from any coast, in a world that has no walls and almost no horizon. Even within the open ocean, there are subtle features that turtles use. Convergence zones where currents meet, accumulate floating debris and small organisms. These zones become traveling ecosystems. A leatherback can move from one convergence zone to the next, feeding along the way, never touching land for months. Convergence zones are dynamic. They form, drift, dissolve, reform somewhere else. The turtles seem to know how to find them, whether through smell, magnetic sense, or some combination. Leatherbacks navigate these invisible features as if they were islands. Without them, the open ocean would be too empty to support such a large body. Sargasso mats are another floating home. The Sargasso Sea, in particular, is a massive accumulation of golden brown floating seaweed in the central Atlantic. Tiny sea turtles spend years inside these mats, feeding on small invertebrates, hiding from predators, slowly growing in a world that drifts at the speed of ocean currents. And under all of this, far below the surface, lie the bathymetric features, the seamounts, the canyons, the ridges. Some of these reach hundreds or thousands of meters below the surface. Leatherbacks dive into them in pursuit of jellyfish that gather around their currents. The deep is also a sea turtle home. Continental shelves, the gradually sloping seafloors that extend out from coastlines, provide other habitats. They are too deep for seagrass but shallow enough for productive plankton and prey. Loggerheads patrol these shelves looking for the slow movement of crabs and sea urchins on the sandy or rocky bottom. Some sea turtles visit estuaries, places where rivers meet the ocean. These mixing zones can be rich in food. Greens sometimes graze on salt marsh grasses near river mouths. Loggerheads may hunt in brackish water where blue crabs are abundant. The turtles tolerate the changing salinity for the meals these places offer. Each of these places, reef, meadow, mangrove, sargassum, open ocean, deep sea, continental shelf, estuary, supports a slightly different kind of turtle life. The 7 living species between them use almost every layer of the warm to temperate global ocean. There is no part of the marine world they have not, in some form, adapted to inhabit. These habitats are connected. Currents carry sediments from rivers to reefs. Migrations move turtles from feeding grounds to nesting beaches. The health of one habitat affects all the others. A sea turtle in its long life often experiences the entire web and quietly serves as a bridge between separate ecological worlds. Tonight, in each of these homes, sea turtles are doing what they do. A green is grazing in a meadow. A hawksbill is sleeping in a reef alcove. A leatherback is descending into deep cold water. A loggerhead is crossing the open ocean. The shapes of the world are full of slow, patient lives. The home of a sea turtle is not really a single place. It is the entire ocean, used in layers, used in seasons, used in long, careful loops that take years to complete. They live in the slow architecture of the planet itself, in the water, the currents, the temperature gradients, the magnetic fields, all woven together. For a long time, scientists believed that sea turtles were silent animals. They have no obvious vocal cords. They do not call across the water the way whales do. They do not chirp or croak the way other reptiles sometimes can. The sea turtle on the surface seemed to live a wordless life. It turns out this was wrong. Sea turtles do make sounds. Hatchlings, especially, make small, soft calls from inside their eggs and after they hatch. Mothers in some species also make low rumbling sounds during nesting. These sounds are quiet, low frequency, and easy for a human to miss without specialized recording equipment. The hatchling calls are perhaps the most touching. From inside the buried nest, in the days before they hatch, baby turtles make a small clicking, chirping sound. The sound seems to coordinate them. It encourages them all to break their eggs around the same time. It encourages them all to climb together. Why coordinate it all? Because emerging together is safer than emerging alone. 100 hatchlings crawling toward the sea overwhelm the predators waiting on the beach. Some are taken, most are not. If the hatchlings emerged one by one, almost none would make it. The synchrony saves lives. Bioacoustic researchers have recorded these underground hatchling calls in several species. The clicks are produced by tiny vibrations in the throat, possibly involuntary, possibly deliberate. The pattern shifts as the nest matures. By the day of emergence, the chorus has reached a peak. Then, all together, the hatchlings climb. During nesting, some sea turtle females make low sounds, almost like a slow breath out, that seem to be related to the rhythm of laying. The exact function of these sounds is still being studied. They may be involuntary, simply the body working hard. They may be a quiet communication to the eggs themselves. Adult sea turtles also make subtle sounds during mating. Underwater microphones have captured low-frequency calls from courting males and slow vocalizations from receptive females. The sounds are not loud, they are not dramatic, they are simply present, woven into the patient rhythm of the species. There is also evidence that hatchlings can recognize their nest's specific environment from the inside. The sand temperature, the orientation, the small chemical signature of the egg chamber. When they emerge, they remember it for a moment, and that memory may help guide them toward home decades later. Imprinting on the natal beach is one of the central mysteries of sea turtle life. Somehow, in the first hours of being alive, a hatchling learns enough about a place that it can find its way back to that exact place after 30 years and thousands of kilometers of travel. We still do not fully understand how. Some scientists believe the imprinting involves the magnetic signature of the beach. Each beach, because of the local geology, has a slightly different magnetic profile. A hatchling fresh from the egg learns this profile during the swimming frenzy. Later, as an adult, it follows the magnetic memory back home. Other scientists believe smell is involved. The chemical fingerprint of a particular beach, the sand minerals, the runoff from coastal forests, the specific seaweeds may form an olfactory memory that the turtle uses to confirm its location. The two senses, magnetic and chemical, may work together. Mothers do not return to teach their hatchlings anything. By the time the eggs hatch, the mother is already gone, often hundreds of kilometers away, perhaps preparing to lay another nest somewhere else. The hatchlings learn nothing from her directly. They are born knowing everything they need. Each hatchling carries the inheritance of every previous generation written into its body: where to swim, how to read the magnetic field, which currents to ride, what kind of food to eat, where eventually to come back. None of this needs to be learned from a parent. The body has already learned. This is one of the strangest gentle facts about sea turtles. They are inheritors of an enormous amount of information, transmitted not through teaching but through something deeper than teaching. Their species is patient enough that the lessons themselves have become part of the body. In Arabata nesting events, the sound of thousands of females climbing the beach together creates its own quiet chorus: the slow shuffle of flippers across sand, the soft breaths, the occasional rumble of laying. From a distance, the beach hums like a slow, patient hive, without language, but full of presence. Other ocean creatures may overhear these subtle sea turtle sounds. Dolphins, with their acute hearing, almost certainly can. Some seabirds may also pick up the chirps of approaching hatchling emergence. The signals are not private. The slow conversation of sea turtles is part of the broader acoustic landscape of the warm sea. Acoustic pollution from human boats and industry is a quiet new threat. The low frequencies that sea turtles use are exactly the frequencies that engines produce. Boat noise can mask hatchling chirps. It can drown out the subtle adult vocalizations during mating. The ocean has grown louder, and the slow voices have less room. Despite this, the species continues. Hatchlings still chirp inside their eggs. Mothers still rumble during nesting. Adults still make their subtle calls during courtship. None of these sounds are loud. None are dramatic, but they are real, and they have been part of the sea turtle's life for many millions of years. So tonight, somewhere in the world, a hatchling inside a buried egg is making a tiny clicking sound that the others around it can hear. Somewhere on a moonlit beach, a mother is making a low rumble as she lays. The songs of sea turtles are quiet, small, and almost entirely unheard, but they are real. Beneath all our noise, beneath every airplane and every car and every voice on every screen, the sea turtles continue their quiet conversation across generations. It is older than language. It is more reliable than language. It will continue tonight and tomorrow and 1,000 years from now in oceans we will not see. The communication of sea turtles is mostly chemical, mostly electromagnetic, mostly internal. The sounds are only one small part. Their inheritance is huge, encoded in DNA, in body shape, in the magnetic memory pulled from the very first hours of life. The species speaks in slow biological dialects we are only beginning to learn to read. And in this slow conversation, even the silent ones say something. A turtle resting motionless on the seafloor is not absent. It is reading the ocean. Pressure, temperature, salinity, distant vibrations. The species is always listening. The species is always slowly making sense of what is around it. The listening itself is a kind of speech. So the songs of the hatchlings and the mothers continue. They are tiny, they are old, they have outlasted dinosaurs. They will outlast much of what we have built, and tonight, somewhere, one is being made and another is being heard in a darkness most of us will never visit. Sea turtles are old, but their numbers are not what they were. In the last few centuries, every species of sea turtle has declined, sometimes dramatically. The reasons are familiar: fishing, plastic, climate change, light pollution, beach development. The patient lineage that survived dinosaurs is now navigating a much faster crisis. Historically, the largest threat was hunting. Sea turtle meat, eggs, and shell were valuable for centuries. Hawksbill shells in particular were carved into combs, jewelry, and decorative objects, fueling a global trade that lasted hundreds of years. The trade has slowed dramatically, but its legacy is still with us. In many coastal cultures, eggs were collected as a seasonal food. A single nest may contain 150 eggs. A single beach may host hundreds of nests in a season. For a long time, these eggs were taken faster than the turtles could replace them. Many populations crashed in this way, slowly and quietly. Today, in most parts of the world, deliberate hunting has been replaced by accidental harm. Longline fishing in particular kills tens of thousands of sea turtles every year. Long lines of baited hooks meant for tuna or swordfish hook turtles instead. Many drown before the line is pulled in. Trawl nets used by shrimp fisheries also catch turtles. For a long time, this was unregulated. In recent decades, simple devices called turtle excluder devices have been added to many nets. They are essentially small escape hatches that allow turtles to swim out before being trapped. Where they are used, turtle survival has dramatically improved. Ghost nets, abandoned or lost fishing gear that drifts in the ocean, are an ongoing problem. They tangle turtles, sharks, dolphins, and birds for years after being lost. Cleanup efforts have begun in some regions, but the open ocean is large, and ghost nets are difficult to find. They remain a slow background threat. Plastic is now a daily threat. Sea turtles eat plastic bags because they look like jellyfish, especially to leatherbacks. Hatchlings can become tangled in microscopic plastic debris that drifts with their floating seaweed nurseries. Even adult turtles can starve with stomachs full of plastic that the body cannot digest. Microplastics have been found in the bodies of sea turtles in every ocean. Sometimes they pass through harmlessly. Sometimes they accumulate in the digestive tract, slowly reducing the turtle's ability to absorb nutrients. The damage is gradual, often invisible until it becomes severe. Climate change brings a different kind of pressure. Sea turtles use sand temperature to determine the sex of their hatchlings. As beaches warm, more females are produced. In some populations, more than 90% of hatchlings are now female. A future generation could end up with too few males to maintain the species. Rising seas also threaten nesting beaches directly. As coastal flooding increases, the beaches where mothers have nested for thousands of years are being eroded or submerged. The natal homing instinct, so deeply written into sea turtle biology, becomes a crisis when the beach itself is no longer safe. Light pollution is a quieter threat. For millions of years, hatchlings have used the brightness of the moon over the sea to orient themselves. Now, on many developed coastlines, the brightest light is the city behind them. Hatchlings turn the wrong way, away from the water, into roads and parking lots and dunes that they cannot survive. Conservation lighting ordinances have helped in some places. Street lights are shielded or turned off during nesting season. Beachfront properties are required to use turtle-friendly amber lights. Where these rules are followed, hatchling disorientation drops dramatically. The fix is not difficult, it just requires deliberate care. Boat strikes have grown with the increase in coastal traffic. Sea turtles need to surface to breathe. Many large recreational and commercial vessels move too fast for a turtle to dive out of the way. Manatees, dolphins, and turtles all share this vulnerability, slow surface breathers in fast-moving water. Fibropapillomatosis, a tumor disease seen mostly in green sea turtles, has spread in recent decades. The cause is debated. Pollution, weakened immune systems, herpes viruses are all possible factors. Affected turtles develop visible growths around their eyes and flippers. Some recover, many do not. The disease is slow and persistent. Yet, alongside the threats, there is recovery. Conservation programs over the last 50 years have begun to slowly reverse some of the declines. Beach protection has reduced egg theft. Lighting regulations have reduced disorientation. Net modifications have reduced bycatch. Public awareness has grown, generation after generation. Volunteers walk nesting beaches at night during peak season. They count nests. They mark new emergences. They watch for poachers. In Costa Rica, in Florida, in Greece, in Australia, in Indonesia, this slow, patient work has become part of local communities. Each night of patrol, each protected nest is small, but it adds up. Hatchling rescue programs operate in many regions. When a nest is laid in a vulnerable location, biologists carefully relocate the eggs to a protected hatchery. The eggs are reburied, monitored, and released as hatchlings when they emerge. The program is intensive, but it has saved millions of small lives. Genetic monitoring has revealed that many sea turtle populations are more interconnected than once thought. A nesting beach in Brazil may share genes with a feeding ground in West Africa. This understanding has helped focus conservation across continents. Protecting a beach in one country supports turtles that feed in another country. CITES, the international treaty regulating trade in endangered species, has been crucial. Tortoise shell trade is now banned in most countries. Sea turtle products cannot legally cross most international borders. Enforcement is imperfect, but the treaty has dramatically reduced the demand that drove centuries of decline. Kemp's Ridley populations, once down to almost 1,000 nests a year, are now slowly climbing again. Green sea turtles in many parts of the world are hatching in greater numbers than in decades. Even hawksbills, the rarest of all, have stable nesting in some carefully managed places. The recovery is partial, it is fragile, but it is real. Recovery is patient work. A sea turtle that hatches tonight will not nest until the year 2050 or later. The conservation of sea turtles is an investment in a future that present generations will not see complete. It is the slow work of patient people who care about creatures that move slowly. Tourism, when carefully managed, supports recovery. People who travel to see sea turtles in the wild bring resources to coastal communities. The revenue supports beach patrols, hatchery programs, and local guards. The slow turtle, simply by existing in a place, can fund the protection that allows it to keep existing. And so the slow ancient lineage continues, despite everything. Smaller than it was, more pressured than it was, but still here. Tonight, somewhere in the warm dark seas, a turtle is descending into the deep. Another is rising to breathe. Another is laying eggs. The patient experiment continues, one generation at a time. The recovery is not finished. It may never be finished in the sense of returning to the abundance of 200 years ago, but the species are not gone. The pattern of slow life continues. The ancient inheritance is still being carried forward. Each new hatchling is a small piece of that long, quiet repair. Humans have known sea turtles for as long as we have lived along coasts. They appear in the oldest art, the oldest stories, the oldest myths. In some traditions, they are world bearers with the entire planet riding on their shells. In others, they are wise, slow elders, witnesses to time itself. In Hawaiian tradition, the green sea turtle, called the honu, is a sacred figure. It represents wisdom, longevity, and the connection between people and the sea. Honu carvings appear on petroglyphs that are hundreds of years old. Modern Hawaiians still treat sea turtles with deep respect. In Hindu and Buddhist cosmology, a giant sea turtle sometimes supports the world. The cosmic turtle, called Akupara, carries elephants on its back, and the elephants carry the earth. This image appears in different forms across South and East Asia, all with the same patient feeling, that the world rests on something old and slow. In coastal indigenous cultures of the Pacific, sea turtles often appear as ancestors and guardians. Some peoples believe their dead return as turtles, watching the village from the sea. To kill a turtle without ceremony in these traditions is to harm a relative. The respect is centuries deep. In ancient Greek and Roman writings, sea turtles were known but mysterious. Aristotle wrote about them, somewhat accurately, somewhat speculatively. They were considered creatures of patience, of long life, of slow wisdom. The Greek goddess Aphrodite was sometimes shown standing on a turtle, symbolizing the slow steadiness of love. In Caribbean indigenous cultures, sea turtles were both food and spirit. The Taino, the Carib, and other peoples developed careful seasonal practices around hunting. Eggs were taken at certain times, never others. Mature turtles were spared. The practices were not just resource management, they were ceremonial, careful, embedded in worldview. Mediterranean coastal communities have nested alongside loggerheads for thousands of years. Greek beaches like Zakynthos and Crete remain critical loggerhead nesting sites. Local people have known the rhythms of nesting since antiquity, sometimes protecting them, sometimes harvesting them, always aware of the patient summer arrivals. West African coastal myths feature sea turtles as messengers between worlds. Among some peoples of Ghana and Nigeria, a sea turtle approaching the shore is a sign, sometimes good, sometimes a warning. The turtle's emergence is rare enough that it carries weight. The slow visitor from the deep is treated as a teacher. During the age of European exploration, sea turtles were found in such enormous numbers in the Caribbean that ships could be provisioned with hundreds of them at a time. Sailors used them as living food storage on long voyages. Whole populations were exhausted in this way in just a few decades. By the 18th and 19th centuries, sea turtle products had become global commodities. Hawksbill shell, called tortoiseshell, was prized for its golden patterns and used in everything from jewelry boxes to eyeglasses. Green turtle meat became a delicacy in Europe, served as turtle soup in fine dining establishments. Asian markets developed alongside European ones. Hawksbill shell carved into hairpins, combs, and ornamental boxes spread through China, Japan, and Southeast Asia. The skill of the craftspeople was real and beautiful. The cost to the species was unsustainable. Both were true at once. Industrial-scale exploitation continued well into the 20th century. Tortoise shell items, sea turtle leather, ornamental shells, all moved through markets that did not yet understand how slowly the species could reproduce. By the time the trade was widely banned, several species were down to a small fraction of their historic numbers. The modern era of sea turtle conservation began in the 1970s and 80s. International agreements like CITES restricted the global trade in sea turtle products. National laws began to protect nesting beaches. Volunteers, often working through the night, began to walk beaches each summer to monitor and protect nests. Today, in many places, that work has become a major part of the local culture. In Costa Rica, in Florida, in Greece, in Australia, in Indonesia, there are communities whose annual rhythms include the turtle nesting season. People stay quiet on certain beaches at certain times. They turn lights off. They let the ancient cycle continue. Aquariums and rescue centers have become major points of public engagement. Visitors who would never see a sea turtle in the wild can stand at a tank and watch one rise slowly to the surface, breathe and descend again. The patience of the turtle becomes contagious. The slowness changes us just for a moment. Citizen science programs have spread. Tourists report sea turtle sightings. Surfers photograph turtles encountered offshore. Snorkelers contribute observations through apps and websites. Each individual record is small, but together they form a slow data stream that helps researchers understand population health and movement. Sea turtles have also become symbolic. In environmental movements, they represent the long, slow, vulnerable, irreplaceable forms that careless human activity can destroy. A single image of a turtle entangled in plastic has changed minds in ways that thousands of pages of climate reports could not. Documentary films have reshaped our cultural relationship with sea turtles. Footage of hatchlings emerging from sand, of leatherbacks descending into the deep, of mothers laying in moonlight. These images now shape how children grow up imagining the sea. The patient turtle has entered the modern shared imagination. Children's books have reinforced this. The sea turtle is one of the most beloved animals in early childhood literature, alongside elephants, owls, and bears. Each generation of readers grows up knowing that sea turtles are gentle, slow, ancient, and worth protecting. The cultural foundation builds over decades. In many places now, sea turtle tourism quietly funds conservation. Boat trips to see turtles in the wild generate income that supports beach patrols, anti-poaching guards, and hatchery programs. The economic value of a living turtle has come to exceed the value of a dead one. This shift has been slow but enormously important. Our relationship with sea turtles, like the turtles themselves, is slowly changing from food to commodity to companion, from hunted to protected, from symbol of luxury to symbol of survival. The relationship is incomplete, of course. It is fragile, but it is moving in a direction that the turtles themselves seem to allow. Indigenous communities continue to play a central role. In many parts of the world, traditional knowledge, often centuries deep, has been integrated into modern conservation. Local hunters become local guards. Old ceremonies become new monitoring practices. The wisdom of patient cultures meets the urgency of modern science. And so when you see a sea turtle, you are seeing not only a living animal, but a long human history. A history of fear, of hunger, of greed, of wonder, of learning. a history of slow respect that took us a very long time to come to, a history that is now somehow still ongoing. Tonight, somewhere, a child, somewhere in the world is being told a story that includes a sea turtle. Somewhere else, a researcher is recording a nest. Somewhere else, a tourist is watching one rise to breathe in the calm of evening. The patient relationship continues, made of many small, careful moments on every coast where the species still survives. We have come a long way tonight, from the warm beaches where the eggs are laid, to the open ocean where the hatchlings drift, through the migrations of loggerheads and leatherbacks, into the seagrass meadows and the coral reefs and the deep cold seas. The world of sea turtles has shown us only a small piece of itself. The turtles we have visited have not noticed us. They will continue their slow lives whether we watch or not. New hatchlings will keep climbing toward moonlight. Old turtles will keep returning to natal beaches. Migrations will keep crossing oceans. Sleeping turtles will keep wedging themselves into coral crevices for the night. Somewhere in the world tonight, a green sea turtle is grazing in a shallow seagrass meadow, the same kind of meadow her great-great-grandmothers grazed in. Somewhere, a leatherback is descending into the cold, dark, deep, slowly, calmly, as her ancestors have done for 110 million years. If your eyes are still open, allow them to close now. There is nothing left to see that has not already been shown. The sea turtles will be here tomorrow, and the night after, and 1,000 years from tomorrow. They are not in any hurry to be witnessed. You can come back anytime. They will still be moving slowly through the warm blue water. Let the slow rhythm of your breath continue, in and out. Sea turtles breathe too in cycles much slower than ours, up to the surface to fill the lungs, down into the patient depths, up again, down again. They have been breathing this way since the time of the dinosaurs. Tonight, somewhere in the patient sea, a turtle is breathing along with you. Thank you for trusting your night to this slow voice. The Circadian Institute exists because there is a need in the late hours for stories that do not demand anything. Subscribing keeps that need answered. Each week, a new slow journey through the ocean made for sleep. Until we meet again, the sea turtles will keep traveling the great oceans. Hatchlings will keep finding the moonlit water. Females will keep returning to the same beaches. The cycle that has continued for 110 million years will continue tonight and tomorrow and into a future longer than any of us will ever see. Good night from the Circadian Institute. Sleep deeply. Sleep well. The sea turtles are still gliding through the warm blue waters. Hatchlings are still finding their way to the moonlit sea. The great migrations are still unfolding slowly across the patient oceans of the world, and tomorrow when you wake, all of this will still be true. Good night.